solve a question in concurrent and coplanar force, but in this case we are told to look for the force and the theta of this vector here, right? Now the question goes like this. It said the force system shown in figure below has a resultant of 200 Newton, right, pointing downwards along y-axis. Compute the value of force and theta required to give the resultant force. Shut again. So from here, what you do is we're going to, we have this way. We know that the resultant force R is giving us the square root of the summation of, if you like, you put f of x or you put h, any of them, summation of f of x all square plus summation of what, f of y all square, right? Now we don't know what the total resultant force is along x-axis and along y-axis, so we need to resolve those components so that we're able to get the total force acting along x-axis. So for this, for the total force acting along the horizontal components, right, we'll say it will be equals to, now if I look at this guy, I will draw a line, I'll resolve it horizontal and what, vertical. If you resolve this, what you have here. So along here we say it is f cos theta, and along here we say it is what, f sine theta, right? This also, I will have do one parallel to this, I'll do one parallel to this. The force is acting outward, so we have this way. So along x we have 240 cos 30, along y we have 240 sine 30. So if we start for along x, this is along x, so and it's facing, this direction is positive, right? So we say that f cos theta. Now along x is going backward, and that is negative. We put minus 500, right? This is facing here, it is what, this is negative here, and this is what, positive, facing forward. We have plus 240 cos 30 equals to what, 0. Now in this case we will say that, we'll stick with this, we'll say f cos theta, we don't know, minus 500 plus 240 cos theta is going to give us what? That will give us 207.85, right? So we have 207.85. 207.85 equals to what? 0. So 500 minus 500 plus 207.85 will give us f cos theta minus, so we have will give us 292.15. We have 292.15 equals to what? 0. Now if I take this to this side, we have the f cos theta will be equals to what? 292.15. Is that taken? This is what we have here. So I'm going to term it. When it's coming here, it will become positive. So term it. Equation 1. Now we've done for f of x. Now we are going to go for what? Summation of what? F of y. So for the summation of f of y means the forces acting along y axis will now be equals to, now let's see, at this point here we have f sine theta is acting along y is positive as vertical force, so we have f sine theta, so we say we have f sine theta, right? And if you look at the next one, the 200 Newton is acting downward, and you give me minus 200 because it's acting downward. And if you come here, it is also acting downward, 240 sine theta, so minus 240 sine 30, right? So from here we equate them to be equal to what? 0. Now we move forward. At this point we have f sine theta minus 200 minus 240 sine 30 is 120 is equals to what? 0. So this will now give us f sine theta, then now we have minus 320 equals to what? 0. And this will be equals to, we have f sine theta will be equals to what? 320. So I will terminate equation what? Equation 2. Now if we divide equation 1, divide equation 2 by 1, so I write dividing equation 2 by equation 1, we'll be having f sine theta all over f cos theta. This will now give us, we have 320 for the up one all over 292.15 for the down one. Now if you look at this very well, this f will equate this f, so we'll be left with cos theta over sin theta, but cos theta over sin theta in your trigonometry is equals to what? Tan theta. So if I input it there, so I will have that my tan theta will now give us 320 divided by 292, 320 divided by 292.15, that will give us 1.095, so we have 1.095. So when my tan comes to this side, the theta will give us tan inverse 1.095. So theta will give us, we press tan inverse of the answer, shift tan inverse of the answer, we'll be having 47.6 degree. So that will give us 47.6 degrees. So we got in the angle. Now the next thing we want to do, if you substitute the angle into equation 1, right, to get the force. So I can put it this way, substituting theta equals to 47.6 degree into any of the equations. So I can choose equation 1, you get the same value. So if I choose equation 1, I have f cos theta is equals to 292.15, right? So we'll be having from here f cos, what is the theta? That is 47.6 is equals to what? 292.15. So if I divide both sides by cos 47.6, I will see that the force now will now give us 292.15 divided by what? Cos 47.6, right? And that will give us, so if I press my cos 47.6, I'll be having 0.674, so it will give us 0.674 all over 292.15. So if you divide 292 that is 292.15 divided by answer, so we have 433.3 Newton. That is our force. If you also put it in equation 2, you still get the same value. So these are our force. So we've gotten the force and the resultant force. So if you look at our question here, we already see that our answer is giving us theta is this and the force is this. Are we together? So if you find this video helpful, please don't forget to click on the subscribe button, and don't forget to share, and also click on the like button. Thanks for watching.